Hello everyone, welcome to the BT Audio Transceiver Introduction. Today, I would like to introduce the BT Audio application for the next generation Bluetooth audio transceiver of Realtek. Today's presentation covers the following topics: application overview, requirements, then mainly message sequence charts, flash configuration and code flow. The last part briefly introduces Find My GFPS Finder, one-wire UART USB mass storage, ACI User Manual and AciHostCLI User Manual. This report is mainly some introductory content, so for some of the technical details, you can understand them in detail through the documentation inside the SDK. BT Audio Transceiver is an application developed based on RTL87X3E Common SDK, which has BT, BLE, and audio capabilities. The ACI host can communicate with the ACI device through the UART interface. The demo structure diagram of transmitter is as follows. ACI host connects with ACI device via UART interface. Through the RTK command set, ACI host controls ACI device into pairing mode, as well as active scanning and pairing headset. In this application, ACI device acts as BLE peripheral. It will advertise and accept BLE connect requests from the mobile phone, and the phone can control ACI device through BLE connection. The audio data flow is identified in figure by the blue line with arrows. Here is receiver demo. In this application, ACI device acts as BLE peripheral. It will advertise and accept BLE connect requests from the mobile phone, and the phone can control ACI device through BLE connection. The audio data flow is identified in figure by the blue line with arrows. For the BT link with the cell phone, ACI device acts as the HF role of HFP and A2DP sync role of A2DP, which can play music and handle phone calls. Next, we introduce the demo of transceiver. As shown in the figure, ACI device 1 supports A2DP sync and HFP-HF, ACI device 2 supports A2DP source, HFP-AG and BIS/CIS. Device 1 is connected to the mobile phone and device 2 is connected to the headset. The two were previously connected through the SPI bus. According to the level of GPIO, the change enables SPI to transparently transmit data. Currently supported transparent transmission functions are A2DP, HFP, and BIS. The audio data flow is shown as the blue arrowed line in the figure. The demo structure diagram of transmitter MP3 is shown below. This demo shows the interactive process of music playback. The format of music playback is MP3. The ACI device is directly connected to the headset, and the host transmits the audio data to the device through UART. After processing, the device can choose to play it locally or transmit it to the headset through A2DP. The demo structure diagram of integrated transmitter is as follows. ACI host connects with ACI device via UART interface. Through the RTK command set, ACI host controls ACI device into pairing mode, as well as active scanning and pairing phone and headset. In this application, ACI device acts as phone's sync role and headset's source role. The audio data flow is identified in figure by the blue line with arrows. Here is the project directory. Our project has three hardware platforms: RTL87X3E, RTL87X3D, RTL87X3EP. Take RTL87X3E as an example. There are three types of images for common SDK: CS pipe stereo, CSLE audio pipe stereo, CSLE audio pipe stereo ULL. Bluetooth audio transceiver application can be categorized into 5 scenarios: BT audio transmitter, BT audio receiver, BT audio transceiver, BT audio transmitter MP3, and BT Audio Integrated Transceiver. The first is the basic function module. The startup and shutdown functions introduced here are controlled using the command of the AciHostCLI tool. When the command of MMI power on or MMI power off is entered, ACI device will reply to the relevant events of the device state, indicating the device status. There have been changes, where 1 means it has been power on, 0 means it has been power off, and 2 means it is shutting down. Transmitter supports source play function, which can transmit mic, line-in, USB, SD card signal to buds through HFP, A2DP, or BIS/CIS. Here we introduce the application of mic as the input source, HFP as the output source, line-in as the input source, and BIS as the output source. First, we use command to set the input source and output source. We use the command of setRoute in mic and setRouteOut HFP-AG. After the settings are completed, we start the input and output transmission respectively, using route in start and route out start. If you want to stop the transmission, you need to enter route in stop and route out stop. The transmission process is shown in the figure. Next is the application of line-in as the input source and BIS as the output source. Compared with the above operation, there are additional steps to initialize BIS. We enter BSRSINET 48K2 bis to initialize BIS. 48K refers to the codec type, and 2BIS refers to the two-way BIS signal. The receiver can be regarded as a headset application. Next, we will briefly introduce the function of making and receiving calls through HFP. As shown in the figure, when there is an incoming call, the ACI device will continuously report the app event HFP call status event to indicate the call status. At this time, you can enter the MMI answer command to answer the call. The command number used here is CMD_MMI 0x0004. At this time, the SCO link will be established and the call will begin. If you want to reject the call, you can enter MMI reject. The following introduces the A2DP transparent transmission function of transceiver, as shown in the figure. A 2DP data can be transferred from the phone to the headset via ACI device 1 and ACI device 2. The SPI role of ACI device 1 is master, and the SPI role of ACI device 2 is slave. It should be noted that when compiling the roles of master and role slave, you must turn on FAP SPI role master and FAP SPI role slave respectively. The AVDTP data format between phone and ACI device may first be different from that between ACI device 2 and headset. To solve this mismatch, the audio pipe is introduced on ACI device 2 to convert the format in the route of phone-ACI device 1 to that in the route of ACI device 2-headset. SPI recommend connection, P0_0, SPI SCK, P1_0, SPI MOSI, P0_1, SPI MISO, P1_1, SPI CS, P2_1, PIN GPIO, and GND of ACI device 1 and ACI device 2, developer can connect according to the pin settings in board.h. The play route of device 2 should be configured to A2DP source through CMD A2DP XMIT set route out. The ACI host sends CMD A2DP SMIT route out control with status param to ACI device 2 to start or stop processing and sending data to headset. Here we introduce the local playback mode, as shown in the picture on the right. To enable music playback, you need to use CMD XMMMI and set the action parameter to XMMMI mode local play, 0x01. The master controller sends CMD XM music command with music session open to start the music playing process. The AciHostCLI command for starting music playing is music open. ACI device requests the first music data frame through event XM music rec frame. Afterward, ACI device will continue to request music data frame through event app event ACK 0x0000 with status CMD set status music REQ 8. The master controller sends session close to end the music playing process normally. The AciHostCLI command for stop music playing is music close. If the ACK status is not CMD set status complete 0 or CMD set status music REQ 8 during playback, the master controller will send session abort to stop the music playing process immediately. The AciHostCLI command for stop music playing is music abort. Based on the integrated transceiver A2DP transmission, A2DP data can be transferred from the phone through ACI device to the headset. We use the command of set route in A2DP and set route out A2DP. After the settings are completed, we start the input and output transmission respectively, using route_in start and route_out start. If you want to stop the transmission, you need to enter route_in stop and route_out stop. Based on the integrated transceiver HFP transmission, SCO data can be transferred from the phone through ACI device to the headset. We use the command of HFP-AG connect 1 when called by another phone. After the conversation is completed, you need to enter HFP-AG disconnect 1. This part mainly introduces the design specifications of BT Audio TRX. It is written to help users easily and completely understand the code flow of an application. The flash configuration in this product is shown in the figure below. The path of the flash map is in SDK bin RTL87X3E flash map config 4M flash_4M flash_map.h. The starting address of bank 0 is 0x021F0000 and the size is 8K bytes. The global and heap regions of memory are configurable, and the corresponding configuration file is located in the SDK board of BT Audio TRX Inc. RTL87X3 MEM_config.h. If the user wants to increase the global size, he only needs to increase the app global size. If you want to increase the heap size, you need to decrease app global size. Note that the sum of app global and heap remains unchanged, so as long as the size of app global size is adjusted, the purpose of dynamically adjusting the heap size can be achieved. The maximum size of the app image is defined by bank 0 app size. Currently, there are a total of 9 DMA channels available for use. Some channels are already utilized or reserved for DSP and log UART purposes. There are 3 channels currently unoccupied. In addition to this, the DSP reserved channel 8 is not used by DSP and is also available for app use. For MP3 transmitter application, transmitter MP3 demo support, due to substantial audio data stream, the UART will dynamically requests 2 channels. In the case of the transceiver application, transceiver demo support, SPI-TX dynamically requests 1 channel, while SPI-RX utilizes channel 8, which is reserved for DMA purposes. The code flow section describes the code flow of the main functions. Below we take the boot function as an example. Functions such as power on, power off and factory reset are realized by transmitting MMI command through UART. These commands are centrally processed in app_cmd general.c, and the used APIs are introduced in the first figure of app_cmd general CMD handle. App handles key message and function app MMI handle action. User triggers the specific key process, then the device would perform related action. If the device performs power on, it will call the function after judging the device state under case MMI dev power on. The above serves as an example. Main code flow parts, basic function, BT audio transmitter, LE audio initiator, BIS, LE audio initiator, CIS, BT audio receiver, BT audio transmitter MP3, UART DFU, acoustics MP. For specific code flow, developers can refer to the corresponding section and click on the link to refer to the corresponding API. Next is Find My introduction. Find My is an application technology released by Apple. It uses Bluetooth Low Energy as the primary transport to interact with Apple devices. The magic of this technology is that the peripheral products that support this technology, such as AirTag, can use the Apple devices around it, iPhone, iPad, AirPods, AirTag, etc., to help it locate even if they do not have a GPS module. The Find My app is where you locate your Apple devices, share your location with friends and family, and locate Find My network-enabled accessories. The app displays the location of findable items and includes additional features to protect your devices, such as playing sound and using lost mode. Find My test. Prerequisite: after the device is powered on, Find Me pairing advertising shall be enabled. 1. Press the button Add Item to enroll one new tag device. 2. Press Other supported items to start scanning for the pairing advertising sent by the accessory. Find My test. 3. When the mobile application scans the Find Me pairing advertising, the following window will pop up, then press the Connect button from the application. 4. Press the Continue button and enter the name, set the icon to complete the pairing session. Next, let's give a brief introduction to GFPS Finder. Apple's Find My device require devices broadcast Bluetooth signals, and the signal can be picked up by any other iOS device to relay that and the location to the cloud, so you can find a lost gadget in more circumstances. Google now looks to be leveraging its 3 billion Android devices to create a similar network. Google's Find My device also require devices broadcast Bluetooth signals, and the signal can be picked up by any other Android device to relay that and the location to the cloud, so you can find a lost gadget in more circumstances. GFPS Finder test. Prerequisite: after the device is powered on, GFPS advertising shall be enabled. 1. After the mobile phone scans the GFPS advertising, a pop-up window is displayed, and the user clicks Connect. 2. User check whether the device is a trusted device and set a screen lock. GFPS Finder test. 3. User adding device to Find My device app. 4. User see device in Find My device app. Let's give a brief introduction to one-wire UART. 2 one-wire UART function is supported. UART 0 and UART 2 are available currently. To enable this function, we should complete configuration as follows. Firstly, PinMux should be configured as UART. If users want to enable 2 or more UARTs, corresponding number of pins should be configured. Currently, UART 0 and UART 2 are available. The macro is configured as UART 0 and UART 2. Secondly, connect the GND, VCC, and UART data pins of the two devices. Thirdly, baud rate should be configured same as the other side. Currently, baud rate is configured as 115,200 through parameter app_cfg_const.data_UART_baud_rate. Next, we will introduce the USB mass storage part. The host and mass storage devices communicate over the USB using the protocols described by USB Mass Storage Class CBI Transport Specification. These protocols are based on the command/data/status style of communication. That is, the protocol's transport command blocks from the host to the device, transport data between the host and device, transport status of the command block from the device to the host. Firstly, according to requirement, you can consult USB spec and configure the USB descriptor. Secondly, if you want to set up the hardware environment, U5V need connect with VADP, and the evolution board connect with host by USB cable. The USB mass storage device will enumerate success, and you can a mass storage device. Next is HID host. A report host is required to support an HID parser and be able to handle arbitrary formats for data transfers, known as reports, whereas a boot host is not required to support an HID parser as all data transfers for boot protocol mode are of predefined length and format. The sequence chart is shown here. Next, let's take a look at the ACI User Manual section. This section gives the command and event collection we used in the application note. First, let's introduce the general format of command and event. ACI command message is used by the host to send commands to the device. ACI event messages are used to send events from the device to the host and consist of fields such as sync word, seqn, length, opcode, parameter, checksum, etc. Among them, the sync word is a fixed value 0xAA, the sequence number range is 1-55, and the length of all parameters contained in the length package is in 8-byte units. The length includes the opcode and parameter fields, and the range is also 1-55. Opcode refers to the operation code of ACI commands and events. Each command or event has a specific number of parameters associated with it. These parameters and the size of each parameter are defined for each command or event. The size of each parameter is an octet integer. Checksum includes data fields from seqn to parameter n. The table gives the commands and corresponding specific commands. Developers can refer to the table for reference. Take ACI_CMD_SDK in the figure below as an example. Its opcode is 0x0000, and the command parameters are event_ID and status. This command is used by the host to respond to the received event. Event ID is the specified event ID, and status is the status of the reply. Taking 0x00 and 0x01 as examples, 0x00 indicates that the MCU can process the command, 0x01 indicates that the MCU cannot process the command. This table gives the commands and corresponding specific events. Developers can refer to the table for reference. Take ACI_event_SDK in the figure below as an example. Its opcode is 0x0000, and the command parameters are CMD_ID and status. This command is used by the device to verify the received command. CMD ID is the specified CMD ID, and status is the status of the reply. Take 0x00 and 0x01 as examples. 0x00 means that the MCU can process the command, 0x01 means that the MCU cannot process the command. AciHostCLI is a test tool running on PC, which is used to demo ACI usage. It can perform CMD or event communication test with ACI device through USB serial port. Tool directory, tool AciHostCLI. 5 steps are needed below. Open config.yml to modify the device's serial port and baud rate settings. Run AciHostCLI.exe to start the application. Execute MMI freeset to perform a factory reset. Enter MMI prompt to power on the device. Wait for event_device_state return 1, power on. The following gives an example of the command to connect BR and human-computer interaction. For establishing BR connections, we provide 2 sets of commands, ACI CMD-BT create connection and ACI CMD-BT disconnect, are divided into connect phone/headset according to whether the connection object is a mobile phone or a headset. For man-machine interface, we provide ACI app CMD MMI, which is subdivided into power on and off, restore factory settings, and answer the phone. Refuse to answer the phone, hang up the phone, etc. Developers can select corresponding commands for development according to their needs. Thank you for watching our MCU SDK introduction. For more details, please read the SDK documentation carefully. If you have any questions, please feel free to contact us. Thank you all.